would be 3 times 5. When you do all that, you're going to come up with negative 35. Whenever your discriminant is less than 0, you're going to have no real solutions. And that boils down from the fact that our discriminant's underneath a radical symbol. So if I was to actually plug it in, we'd have plus or minus an imaginary number. All right, so that one is no real solutions. Our second one, you cannot put it in the discriminant as is because you have to have a 0 on the other side. This has to be 0. To make it 0, I need to subtract 4 on both sides, which will give me 2x squared minus 3x minus 2 equals 0. My b squared would be negative 3 squared minus 4 times 2 times a negative 2. Right there, I already know that there's 2 possible answers. Because this is going to be a positive, this is going to be a positive, so we already know at least the answer is going to be 2 real solutions. Boiling this down, we're going to come out to a positive 25. You okay, Mark? It's going to be a positive 25, which is going to be 2 solutions, which a shocking number of people in this class did not get correct, unfortunately. Perhaps I should weight more of this because I haven't really been taking off points. Maybe I should start taking off points. Gives me something to think about. All right. But anyway, that is using discriminant to figure out how many solutions you have. All right, questions from the homework. Number 1 was wrong in the answer key. It was negative 4, positive 1. Adri.
Can you do 83? Because I did the quadratic thing. Is that what it's called?
Quadratic formula?
Yeah, and I got different answers.
You got different answers than I did?
Yeah.
Well, probably completing the square is going to be a lot easier than the quadratic formula. Well, let's just see here. Okay, we'd have x squared plus 6x minus 72 equals 0, right?
Yeah.
And then you want to see it as the quadratic formula? Sure. Okay. So we're going to have negative b, which would be negative 6, plus or minus the square root of 6 squared minus 4ac. And that would be all over 2a, which would be 2 times 1. Let me just shortcut this. So we'd have 6 squared minus, well, it would actually be plus. So yeah, this would be negative 6 plus or minus the square root of 324 divided by 2, which would be negative 6 plus or minus 18 divided by 2. Is that what you had?
Yeah, I switched the denominator.
Oh, okay. So you know where the mistake was? Okay. But it'd work. I'd rather complete the square on that one because completing the square would just involve keeping the 72 on the side it's already on. That's kind of the sign that I wanted you to complete the square because I kept your C on this side. And so completing the square would have just been plugging this number in, that number in, and taking the square root, which the good thing about completing the square, in this case, there's a lot less room to make mistakes on. Yes? What about it?
Well, I did, and I have a completely different answer.
How did you do it, I guess?
First, I found the lowest common denominator.
Which would work.
So I didn't really get it.
Okay. Well, cross multiplying is probably easier way to do it on there. But if you multiply by the lowest common denominator, it would still come out to the same thing because the lowest common denominator would be 3 minus x times x plus 7 And if I multiplied that all the way across, taking this, distributing it in, my 3x would cancel out, and I just have x plus 7 times x minus 12, which is right here. And then when I distribute here, my x plus 7s would cancel out, and I have x plus 4 times 3 minus x, which I do have over here. It should be 3 minus x, not 3 plus x. But it should be a 3 minus x. But it all worked. I mean, I fixed it, I think, down here. Yes, I did fix it. All right, but it is just cross multiplying. All right, other questions? Yeah, Nate.
79.
So a double square root, we are going to have x squared equals the square root of 2. When I take the square root of both sides, we're going to have something that looks like this. X equals plus or minus the square root of 2. But what's actually happening here is, remember that the square root of 2 is just 2 to the 1/2. So a square root of square root of 2 would be 2 to the 1/2 to the 1/2. And whenever you raise a power to a power, you multiply them. So that's 1/2 times 1/2, which is going to be 2 to the 1/4. So that is a perfectly valid way to write it. However, another way to write that is just going plus or minus square root symbol. Now, square root implies there's a 2 there. In this case, there's actually going to be a 4 there because it was to the 1/4. So it's square root to the 4th, or a 4th root. Other questions? All right, then today we're going to get into applications. I'm not going to check your homework till tomorrow, primarily because a lot of people weren't here in class. They're all in the musical, so I'll check it tomorrow. Plus, there's going to be no homework due tomorrow. This assignment's going to be due Friday, and tomorrow's going to be a work day to finish it. All right, so we're basically doing just word problems. What was that?
You mean due Monday?
When did I say?
Friday.
No, it's due Monday, because we have a work day on Friday. Maybe I flipped those. All right, so it'll be a work day tomorrow for these. All right, so we have a word problem, and we have Daniel who's driving. Good? Okay. So we have Daniel that's driving. And if you'd read this question, you'd find out that he's going 2 directions. He's going east and west. And what's most important about that is he's going 2 different directions, and it's a distance problem. So you should make a table where you have distance equals rate times time. And I'm telling you how many people would have got so many more points on the test if they would just make the table with distance equals rate times time instead of coming up with some brand new tables that don't do anything. Any time that you have distances in there and miles per hour, it's always going to be distance equals rate times time. Every time. Whether you need a table or not, it's going to be dictated by how many things you have, but you're always going to be doing distance equals rate times time. Always. All right, so we have distance equals rate times time. Now let's read this first sentence. It says, it took Daniel 30 minutes longer. I'm going to just highlight that, but I'm not going to use it yet. We're going to use it later on. So it took Daniel 30 minutes longer to drive 275 miles on I-70 West. Okay. Of Green River, Utah. Then it took him to drive 300 miles east of Green River. So our 2 directions are east and west. So we're going east and west. Yes, he's carrying cantaloupes. And I can also pull from that one sentence that he's going 275 miles west and he's going 300 miles east. So those are going to be our total distances. East was 300 miles. West was 275.
Wait, what? You just flipped it.
Oh, I did just flip it. You are correct. I actually flipped my east and west from last time. So we are going to have 275 miles west, and we are going to have 300 miles east. All right, continuing to read. We have, because of a sandstorm and a full load of cantaloupes, he averaged 10 miles per hour less while traveling west of Green River. So I'm going to highlight that statement. He's going 10 miles per hour while traveling west. So 10 miles per hour less. So what I'm going to do is I'm going to let the rate for traveling east be x, and the rate that he's traveling west is going to be x minus 10 because it is 10 miles per hour slower. All right, what was, in mine it switched to a girl all of a sudden, I guess. But yours should say, what was his average speed going east? So what I'm looking for is I'm actually trying to solve for that x, that speed going east. Now time, I know it says 30 minutes longer, but if I was to actually put that in the table, we'd have to have a y and a y minus 30 or y plus 30. I don't want to introduce a new variable. So instead, to get that time, and this works 90-some% of the time. Time. If you have distance equals rate times time, we can redraw this or rewrite it as time equals distance divided by rate. Pick your head up, Logan. So that means our times are just distance divided by rate. So in this case, it'd be 300 divided by x. And in another case, it'd be 275 divided by x minus 10. The reason I want to do that, I don't want to create a whole new variable if I don't have to. And we don't have to, so we're going to use that x. In fact, if we created two new variables, it'd be very difficult to solve. All right, so now I have two times. I have rates. I have distances. The most important thing right now is this 30 minutes longer and these two times. I'm going to change this for a second. Rather than be 30 minutes longer, if I said the two times were the same, you could set up an equation saying, well, this equals that if the times were the same. But based upon this, the times aren't the same, but they're pretty close to being the same because, let me just plug that in. It took 30 minutes longer to drive west. So our west was a half an hour longer. It took a half an hour longer. So once again, if the two times were equal, we could set up the equation 275 over x minus 10 equals 300 over x. And that would be good if it said both times were the same. Both times are different though. So let's break this down a little bit further. If this was 30 minutes, this one would be 60 minutes. If this was 90, this would be 120. In order to come up with an equation that they're equal, I would have to say something like 30 plus 30 would equal this 60. So once again, if this was 30, this would have to be 60 because it's a half hour longer. So in this equation here, we have 275 over x minus 10 is going to equal 300 over x as long as I add 30 minutes or a half hour onto it, because that is our shorter amount of time. So you're going to add that 1/2 to the shorter trip.
It can't be 30.
It can't be 30 because we're in miles per hour. If you change it to miles per minute, then it could be minutes. But right now we are in miles per hour, so we're going to do that. Yeah?
Wait, why do you have the 1/2 to east time?
Because let's look at it this way. So I have east and west, right? So let's use my hands. This will be my east, this will be my west, so the top bottom. Right now, west is half an hour longer. So it's the time is, so if this was 60, this would be 30. To make them equal, I have to add to this side. You have to add to the shorter trip. And once again, like I was saying before, so maybe I'll put this in purple. I'm not going to leave it up there. But if this was 30 minutes, this is just hypothetical, then this would have to be 60 minutes because it's a half an hour longer. So I'd have to add 30 to this one for those two things to be equal. That is the hardest part about the problem, is to figure out which side to add the 30 minutes to. And I promise you, I will not make fun of you if you do that hand thing on the test. I have my geometry students do that all the time when they were comparing numbers and coming up with equations just like this. Honestly, it just makes it easy. Which one takes longer? Make that your higher hand. The other one you have to add to. Or likewise, you could subtract. So since west takes a half hour longer, you could do 275 divided by x minus 10 minus 1/2, and you get the same answer. All right, that is the setup to the equation. That is just the start of these, because we do have to solve them, and they're going to be slightly more difficult to solve. So the first thing I'm going to do to solve it is I'm going to come up with the lowest common denominator, which is going to be 2 times x minus 10. Which I'm going to multiply both sides by 2x times x minus 10. Now follow along with what I'm doing. I'm going to distribute this to everything. So I'm going to first distribute that 275 over x minus 10. In this case, my x minus 10s would cancel out. I'd just be left with the 275 and the 2x. I'm going to erase that because it's not going to stay gone. So we are going to just have the 2x and the 275 remaining. That's going to equal, I'm going to distribute this to that 300 divided by x. Once again, what I'm distributing would go on top, so the x's would actually cancel out. And I'd be left with that 2x minus 10 and that 300. So I'm going to have 2 times x minus 10 times that 300. Finally, I'm going to distribute this to the 1/2. Once again, that 2 is the denominator, so our 2's would actually cancel out. And I would just be left with the x minus 10, and that 1. So we are going to have plus 2, nope, that's gone. Just the x minus 10, and the 1. All right, let's go ahead and start simplifying this. Well, 2x times 275 is going to be 550x. That's going to equal, I'm just going to do the 2 times the 300. If you want to go further, you can. I just don't want to make any mistakes. So I'll have 600 times x minus 10. That's going to be plus x times x is x squared, minus x times 10, which is 10x, all times 1. No, let's not put it as an exponent. There we go. All times 1, so I'll just stay negative 10x. As I'm running out of room, I'm going to go to the next slide with this. So I'm going to copy it. I'm going to paste it down on the top of this one. All right, so currently I have 550x equals 600 times the quantity x minus 10 plus x squared minus 10. In this step, I'm going to simplify everything all at once. So I'm going to subtract 550x from both sides. No, I forgot to distribute the 600. Let's do that first. Let's not try to do too much at once. So I have 550x equals 600x minus 6,000 plus x squared minus 10x. Now I think it's safe to do everything else. So I'm going to subtract 550x from both sides. And what I'm also going to do is I'm going to combine that with that negative 10x. I'm also going to rearrange everything. So the first thing that's going to happen is this side is going to turn to 0. We'll have 0 equals x squared. Now I have 600x minus 550x, which is 50, minus 10x, which is going to be 40x minus 6,000. Two routes here. You could plug it into the quadratic formula. You could complete the square, or you can do a super simple check, which I do every single time my leading coefficient is 1. I'm going to see if I can just guess and check a factor for this. So once again, to guess and check a factor, I'm looking for something that multiplies together to give me negative 6,000 and adds to give me 40. I'm not going to spend a ton of time checking it, but it's a good one to check on here because it's a pretty basic multiplication, because it'd probably be the first one I would check. Because I'm looking at 6,000, I'm like, well, 60 and 100. 60 times 100 equals 6,000. And the difference between 60 and 100 is 40. So this is a very good one to be able to factor. And in fact, if you could just see that, you could also make your two columns, but I'm just going to do that guess and check kind of method, where I'm just like, well, I know it's going to be a binomial times a binomial. It's got to equal 0. Two numbers that multiply together to give me 6,000 are 60 and 100. I know the difference between them is 40. I just got to figure out which one needs to be negative and which one needs to be positive. And since when they come out, I need to come up with a positive 40, it must be a positive 100 and a negative 60. So that is going to give me x equals 60 or x equals negative 100. Those are not our answers. And if you left it like that, you would lose points because one of those doesn't even make sense. One of them says that we're going to go negative 100 miles per hour. Because as a quick reminder, our x was what we're solving for, which happens to be a rate of speed. Negative 100 doesn't make any sense, so that can't be a possible answer. So we're left with x equals 60, so it's got to be 60 miles per hour. On these types of questions, I do need to see your final answer being 60 miles per hour. Otherwise, you're losing points. Questions on that one? If you were good on these word problems and you follow along like you should have been doing, our rates problems and our tables should be set up the exact same. Nothing new. The only thing that changes is kind of how we set up our equation. All right, in the homework, a lot of them are going to be modeled after this. I'm going to give you an equation that models a real-life instance. You have to apply something to it to figure out where your values go into it and how to solve it. So in this case, we have a tennis lob. It can be used to buy time to get into position. The approximate height s in feet for tennis ball that is hit straight upward at a velocity of whatever speed we have, feet per second, from a height of s sub 0 feet is modeled by that equation where t equals our time. This is a very general equation you're going to see a lot. You're going to see it, I think, twice in the homeworks, and you see it a lot whenever we're talking about physics and doing the overlap with pre-calculus, because this is a physics problem, but it's a very simple physics formula that we can apply to the quadratic formula. So it shows up a lot. So let's break it down. Whatever's on the left-hand side here, right now we have an S standing for, and that's what we'll do in the homework. That S is always going to stand for our height. That is that height in this problem of the ball after a certain given seconds. So after 3 seconds, if I plug in 3 into this equation, that's the height of the ball at 3 seconds. And I'm specifying the height of the ball after 3 seconds because if we look at that S sub 0, that is the initial height. That's the height the ball starts out at. And finally, that V sub 0, not only is it our velocity, it is more specifically our initial velocity. Not too important here, but in physics it really is because you lose velocity as you start traveling. That would be a different formula, and we're not going to worry about that. So all we care about is our initial velocity, our initial height, and t is our time, and the left-hand side is our height. So the question here, question A, just says, use the figure above to estimate the time that it takes the ball to return to the court when it is hit straight upwards with a velocity of 60 feet per second from a height of 5 feet. So let's break this down a little further. So we start at a height of 5 feet. That is our initial height. That is why our graph does not start at 0, 0. It starts at 0, 5. Notice it starts halfway between because we start at 5 feet. All right, then our ball goes up and it comes back down. We are looking for when the ball returns to the court. Well, the ball is going to return to the court when the height is 0. So I'm looking for when is S equal to 0. Well, height or S values are on our y-axis. So that's going to be this point right here. Well, that point right there is going to be somewhere about 3.7, 3.8. Maybe you could persuade me into thinking it's 3.9 seconds. All valid answers. So we're just going to say about, I don't know, 3.87. Do we have a preference?
8, 9.
8, 9. Let's leave it to the 10th place because we're just guesstimating.
9.
9.
3.8.
3.8.
3.7.
3.7.
You know that's 3.8.
I know, yeah.
Yeah. 3.8.4.
Yeah.
Wait.
3.8.4. Yeah, because what we're going to do next, we're actually going to solve for it. Solving for it is not that hard in this one because we know all the values. It really is just solving for x. So it says find the actual time using the quadratic formula. We are given our initial velocity. That is going to be 60 feet per second. We are given our initial height, which is 5 feet. And we are also given the height we're looking for, and that's s equals 0. The only thing we're not given is our time because that's what we're looking for. So when we plug all of this into our equation, we are going to get 0 equals negative 16t squared plus 60t plus 5. I'm going to copy all of this and put it on the next screen. So if you're missing anything, it will be transferring over. Make your life easy. You can use your calculator on the test. When I ask this question, do you think I'm looking for 6 plus square root of 200 divided by 2 is your answer? No, I'm not. I'm looking for how many seconds? Just like we had there, I'm looking for 3.8. So this is going to be a problem you're going to use your calculator on. You are going to use your calculator on. So do not waste a whole bunch of time simplifying down to the very end and then plugging in your calculator. This is exactly how I would solve this using my calculator. I would do x equals, well, first we're going to need to actually plug the stuff into the quadratic formula. So we have negative 60 plus or minus the square root of 60 squared minus 4ac, which is going to be 4 times negative 16 times 5, all over 2a, well, that's going to be 2 times a negative 16. The first step I would do in my calculator is I probably don't want to input this every single time, or both times, because there's a chance you're going to make a mistake. So what I'm probably going to do is, in one step, I'm going to plug all this in my calculator to see what's underneath that radical. So I'm going to come up with negative 60 plus or minus the square root of 39 something. You got it? 3920. Divided by negative 32. You could make these negatives cancel out, which should be fine. I'm just going to leave it as is because this is exactly how I'm going to plug it in my calculator. All right, I'm not going to simplify it any further because I'm not getting any points to simplify it. I'm getting points to get a decimal out. I'm looking for an actual answer. So we're just going to go to our calculator. We're going to go to our calculator. I'm going to turn that bad boy on. And I'm going to type in that numerator. I'm going to type in negative 60. And it's plus or minus, so I'm going to do plus first. So we're going to do the square root. Make sure all my numbers are right. Square root of 3920. Oh, that didn't make a 0. That was a 2. There we go. That is now my numerator. I'm going to hit enter because I know that's my numerator. Now all I have to do is hit divide. Divide will automatically let your calculator plug that in. Now that number is in my numerator. Now I'm just going to divide it by negative 32. And I come up with negative 0.08. That does not make sense in the context of the problem. They're saying at negative 0.08 seconds, the ball is at 0, which it is. According to our graph, that is correct. Because the 0 they're actually finding is the one right before they picked up the ball. All right, they're saying if you go back in time, then it hits the ground. But that's not one of our valid answers. So I'm not even, you can write it down and say it's not a valid answer. But we're going to go to the next one. And that's going to be negative 60 minus that square root of 3920. to 0. We're going to hit enter, and we're going to divide that by that negative 32. That's a 33. That's a 32. Hit enter. It is 3.83 seconds. I would just round it to 3.8 seconds because I didn't ask. I didn't ask for you to round it. And just in life, if you aren't asked to round something, usually to the 10th is a great way to do it. All right, unless you know from context clues, like if it's dollars and cents, then you round to the hundredths. But if it's like seconds and I don't ask you, round to the 10th. All right, so it's just going to be 3.8 seconds, and that's what we came up with for the other one. Or 3.8.4 if you round wrong and you put points in weird places. All right, any questions on either one of these two? I got asked the question, am I going to put these on the test? And yeah, word problems will be on this test.
So these bad boys are going to be on the test?
Don't use my saying against me. Never. So you'll see in the homework there's 2 speed ones, I believe. And there are several ones where you are given an equation, you have to interpret how to solve them. And then there's a bunch of random ones. I think the hardest one is 111. I think that's one of the hardest ones. Just a reminder, this is not due tomorrow. This is due Monday. So pay attention. I'm talking, and this is important. Do not just go online and look at the answer key and just copy down the answers tonight. The reason why the answer key is on there tonight, I wasn't even going to put it on there, is because people are going to do them, and they just want to make sure they have it right. And maybe they have like a small step wrong, and they want to check it. I don't want you guys just, I don't know how to do it, so I'm going to look online. You know, spending that 5 seconds, because I know who does that. I looked at your tests. I graded your tests. I graded the ones that just had nonsense for tables, and they just drew a square because they knew they were supposed to draw a table, and they had no idea how to put anything in. Those are the people that just go online and just copy down exactly what I do. You don't learn anything by copying stuff down. You have tomorrow to work on this in class and to ask questions. I will have answer guides in class tomorrow, so you can check your answers as you're doing it. Do not just do that thing where you spend 5 seconds thinking about it. Oh, I can't do it. Look at the answer guide. Oh, I could have done that, and then copy it down. You didn't learn anything. You learn stuff by challenging yourself and just using the answer guide to guide you, and then ask me questions tomorrow because I can guide you a little better than the answer guide. All right, let's use the rest of the class to